And we are live. Welcome everybody to this early morning webinar. I'm Chris, I'm the CEO of Data-Minded, and I'm joined by Frederick. Frederick is a data engineer at Data-Minded. He has a voice, you'll hear it soon. So today I invited Frederick for a webinar because we're going to talk about a bit more of a complex technical topic, which is cross-DAG dependencies in Airflow. It's one of those lesser known features, and it's also not super trivial to understand, but if you know well how to use them, your pipelines become a lot more scalable and manageable, if you will, right? So without further ado, I'm going to give the floor to Frederick, and I'm going to let him share his slides actually, and we can get going.
So first I will show you some slides about cross-DAG dependencies, when to use them, why to use them, and how to implement it. And then after the presentation, we can go to a little demo where I will give some examples. And then in the end, there is time for some questions. So here are some references. There's a blog post about cross-DAG dependencies. Also, the examples that I will show later on in the demo can be found on the Hitp page that you can find here. And then let's start with the very basics. We have Airflow, and in Airflow we can have DAGs and tasks in DAGs. Here on the slide I show you 3 examples. So every color represents a different DAG. So for example, you can have an ETL DAG, a dashboarding DAG, marketing automation DAG. And typically what is done, what are the definitions to create a DAG? You need to group tasks together with the same schedule, or that adhere to the same project or process, or managed by the same team. These are the general rules on how to define the tasks that group together and form a DAG. Then when do we have cross-DAG dependencies? This can happen when some tasks depend on each other from different DAGs. And here on the slide I have drawn some arrows to indicate how this can happen. For example, when your data is loaded, you want to start your dashboarding DAG, and you can also start your marketing automation DAG, but your dashboarding DAG can also depend on several mails, or did the mails arrive, yes or no. So there can be links between different DAGs. And then you need to know how to implement these cross-DAG dependencies. There are 4 main strategies, or 4 commonly known. There are others as well, but these are 4 commonly strategies, and I will go over them in the next slide. So first, the trigger. This one is the most basic one. It's simply, so you have in the upstream DAG that you can see here, the purple one. There you can have a trigger operator, and it simply triggers downstream DAGs. So you can select which DAGs you want to trigger. And it's a push-based principle that works as follows. So here you can see a piece of code from the upstream DAG, the downstream DAG, and it's very simple. So you have the trigger DAG run operator, and there you define the downstream DAG that you want to trigger. So when this upstream DAG activates, and if it contains this trigger DAG operator, then it will trigger the downstream DAG. Here, you trigger it by identifying the ID of the downstream DAG. And then there is an optional thing, what you also can do. You can pass a message to your downstream DAG. So for example, this can be the date at which this upstream task is executed. Then you can pass it to a downstream DAG. The downstream DAG can then read this date. Okay, so then the second one, it's sensors. It's a little bit the opposite. So instead of pushing downstream DAGs, here with sensors, we are going to wait for upstream DAGs or tasks to finish. So it's a pull-based principle, and now we include the sensor operator in the downstream DAG. Here are some additional features and properties of this sensor operator. So it works for a single upstream task. It also works for task groups or an entire DAG. So it's quite flexible. There is also an additional operator, the marker operator, and this one you can optionally include in upstream DAGs. And I would recommend it because it gives you more visibility. If you're navigating in the code and you are in the upstream DAG, you can clearly see, okay, here is a link with the downstream DAG, but it's not necessary, it's optional. It should also have a schedule. So both downstream, upstream DAGs should all have a schedule. And then this is quite important to know how it works. So the downstream DAG runs if all the upstream DAGs have the same execution date.
So if it doesn't have a schedule, it will never, the sensor will never be activated and it will never be triggered.
Yes.
Okay. Got it.
So how does this scheduling work? So the rule is here, it's written down below. The downstream task runs if the upstream tasks have the same execution date. So the execution date, I marked it with the dotted dashes and the balls. So if we have a green dot, then it means that the run was successful. So here in this case, it's successful. Here it will be not successful. So here downstream DAGs, so it's a little bit complicated because the different DAGs have a different scheduling frequency. But if we look to the downstream DAG, at the point that the downstream DAG will have its schedule and start its task, it looks to the upstreams and checks if the run was successful, yes or no. If they both are successful and are on the same execution time, then it will run like here. If one of them is not successful, the downstream task will fail. I will also show this later in an example. Sometimes it can also happen that the execution time is a little bit shifted. So if one of the upstream DAGs is a little bit shifted in time, then we will never have the same execution date for all the different DAGs. And in this case, the sensor task will never work, but luckily there is a solution for this. We have the execution delta argument in the sensor operator that can play with time. So then you can virtually shift the time a little bit such that it matches. But I will also show this later in the examples. So here is an example of the downstream DAG with an external task sensor. So what you do here is you identify the upstream DAG and the upstream task, which is a marker here. You can have a timeout, so the time that it keeps checking for the upstream to finish when it has a successful state. Here it's in this case, it checks for 30 seconds whether the upstream task reached successful. And then here, this is what I said in the previous slide, you can have an execution delta, which shifts the time of this task virtually with 2 minutes. And the goal of this is, so you want to include this to match the execution time of your upstream DAGs or tasks. Here is the upstream DAG, where I include an external task marker. This one, it was optional, like I said before, but it has some advantages. So there's a clear dependency in the code, you can directly see it. And there is also an extra button that appears in the user interface when you include this. I will also show this later in the demo. And then we have a third option, which is the dataset dependency. This works on a little bit different way. So we have upstream DAGs, we define datasets and outlets, and then when an upstream DAG or a task in an upstream DAG runs, it modifies a dataset, or it's at least a virtual modification. Airflow marks this as modification. And then we can schedule a downstream DAG, which is dependent on datasets, one dataset of multiple datasets. And then when all the datasets are modified, this downstream DAG will run.
There's a question from the audience, from Olivier. He says, so I'm trying datasets and I'm looking for more complex capabilities, like run once dataset A is updated, or at cutoff time 6 a.m. if the dataset is still not updated, or run once dataset B is updated, but only once a day. Is there any that kind of advanced behavior? Have you encountered it?
No, not yet. I didn't go in too much detail in this logic. I know you can have some logic with sensors. Maybe you can also apply it here. I didn't do it yet. But at least in the arguments, you only specify in the downstream DAG, you only specify the data set. So I don't think there is the possibility to include more logic. What I recommend, if you work with timing, like you say, you have like the time 6 a.m. If you really want to run a DAG at a specific time, then I would recommend to use sensors.
Yeah. I think here that there is this Boolean, like ideally run once dataset B is there. If dataset B doesn't arrive, start at 6 a.m. So maybe you need both or something. And if one of like either the sensor passes or the dataset arrives, then you can do the downstream thingy. Yeah, it will be more complex indeed, Olivier. All right.
So here a very simple scenario. We have our upstream DAG, and here step 1, you can see we define a data set, which is not a real connection to a data set or a table. It's just you can write whatever you want here. It's a string identifier, and then you identify the data set in your operator that modifies this data set. You define it as an outlet, and then Airflow knows, okay, this data set is coupled to this task. And then in the downstream DAG, you can include the data set as the schedule. You can also include more data sets if you want.
So it's really just a dummy way of communicating that a data set has been delivered, but it's all fake, basically.
It's all fake, yes.
Airflow is still not aware of any data set that was actually published in any of the data lakes or whatever.
Yeah, indeed. So it has some advantages, like you don't need to set up everything and connect Airflow with all the data sets, which would also be a hurdle. It can be a disadvantage, like if there is a mistake or another instance is updating the dataset, which is not Airflow, then it's not aware of it.
Yeah, and also I guess the other issue you can have is that you do update the dataset, like with your Airflow DAG, but you basically mess up the DAG here and you don't parse the string correctly or whatever, and then so your dummy string doesn't do anything, right? Yeah, okay. But yeah, still fair. All right, cool.
So how does it work? When will the downstream DAG run? So here it's written below. The downstream DAG will run when all the upstreams are at least once updated. So here we have the 2 upstreams that modify 2 datasets. And then when the 2 datasets are at least updated once, the downstream will run automatically.
So you do not need a schedule then?
You don't need a schedule, it will all go automatically. So therefore, that's what I said previously, when you want to have some time control. So for example, this DAG needs to run at 6 a.m. or p.m. You can include a sensor in an upstream DAG, or I would recommend to work with sensors.
Yeah, indeed.
Because there's no time control here in this dataset scheduling.
Yeah.
And then so the last one is by use of the API, a simple Hitp operator. This is also basically very similar to the trigger operator, but just works over different environments. So the 3 previous are mostly used within an environment when you just want to have some connection between DAGs. If you want to have connection over environments, then this won't work anymore, and you need to use the HTTP operator. And here I also show a very simple example. You have the DAG, and then we create a task, simple HTTP operator. We also need to set up in Airflow a connection to the different environments. We need to specify an endpoint, and here you need to we need to include the ID of the downstream DAG. We have to specify the HTTP method, and then the header, which is the one that you define here. So it's JSON. You can also specify the date that you want to execute the downstream DAG.
But the endpoint has to be on the same server, or what? Can you point to a completely different Airflow server somewhere? Because here the endpoint is /API/v1.
I think you can modify this.
Yeah.
I didn't try it yet, but you need to set up the connection in your Airflow, and then you'll find it.
Yes. Yeah, you point. Sorry, now I'm with you. Like the HTTP connection ID, and that's also where you set the credentials. Like if you have API,
there you do all the
keys
configurations.
Yeah. All right.
Okay, so these were the 4 different methods. So here we compare them. So we have the trigger, sensor, dataset, API functionality. The trigger, an upstream that triggers downstreams. Sensor is a downstream that waits when upstreams successfully finished or failed. You can also set this. The dataset methods just updates datasets and checks modification of the datasets. And the API is similar to the trigger, that it also triggers downstreams. Then what's the coupling principle? So it's basically all time-driven except for datasets, which is event-driven, which can be quite interesting. Then we don't have to control all the timing and scheduling anymore. The operator type. Then
so for the trigger coupling, it's also time driven. So your downstream Airflow DAG still needs to run on a schedule if you want to trigger it, or no?
You can both. You can.
Okay, you can do both. Got it.
But I mean timing. So it's you need to time the upstream has a timing.
Yeah.
So and then okay, you set the timing of the upstream, which will be.
And that will result in a trigger, and then that's okay. So in that sense, it's time driven. Yeah. While the dataset, you can deliver a dataset from 5 different DAGs, and your dataset DAG doesn't care about which DAG triggered it. Okay, got it.
Then dependency scope, so you can a task that triggers an entire DAG. With sensor, you have a little bit more options. You can trigger, or you can wait on a task, an upstream task, wait on upstream task groups, or an entire DAG. Datasets, it's always you need to define the outlet at a task and set the schedule of a DAG. And then the API, it's also task to DAG usage. So the trigger is 1 to multiple. You have one upstream task that can trigger multiple. Sensor is vice versa. Then the datasets, you can have multiple outlets, and you have also a downstream DAG that waits on multiple datasets to modify. And that is in different environments. And then the minimum required version here, attention is set on the dataset, which is quite recently included as compared to the others. So if you have an Airflow that's older, then you cannot work with the dataset. And then I recommend to update your Airflow instance.
Which makes sense for now at 2.7 or something, right?
Yes.
Something like that,
yeah, indeed. Okay. So then we can now go to some examples. So if you go to the GitHub page, you can click on the Hitp icon, and then there will be a Hitp icon that's opening.
So you have an open source project?
Yes.
Yeah, okay. That will be shared after the webinar then. Maybe it's shared in front already? I don't know.
I don't think so.
Okay, yeah. But so we'll share the link to the GitHub page afterwards, and you can try from there.
Yes. If you open it, this is the Hitp that will open, and there will also be an Airflow instance that you can see here. I made 4 examples, 1 trigger, 2 with sensors, 1 dataset. And let's start with a trigger. So here I have an upstream DAG that I define here. I start with a simple bash operator. I include a first trigger operator and a second trigger operator. So you can see that this one will trigger this downstream DAG, and this trigger operator will trigger this downstream DAG. And then I also included an optional configuration parameter, the message to pass down to the downstream DAGs. Then here is downstream DAG A. Here I don't set a schedule, so it was a question before. Here in downstream DAG B, I set a schedule, so it depends on what you want. And then we have just a normal operator that can extract the message that we got from the upstream one, and we can put it in a bash command. Here I do something very similar, but then with a Python operator, I have a print Python function. We also take the message and we print it.
Yeah.
Okay, then we can see what happened if we trigger. So here it's the upstream, the trigger upstream DAG. I'm gonna trigger this one. And then now the downstreams need to be triggered. Example here. So yeah, you can see that now.
Yeah, it has run one more time. It's actually like 4 DAGs running now.
Yeah, these are time-based.
I got it. And now, yeah, trigger downstream DAG as when. Yeah.
So we can also have a look in this downstream. So you see there's another option. We will have a look to the logs to see if the message is yes. So the message has arrived from the upstream DAG. So this was a very simple method from an upstream DAG where we include a trigger operator, and it can just trigger several downstream operators, and you can pass a message, which can be, for example, a date. Okay, then we have a second option, which is the sensor. I will first go through the code. So we have the upstream DAG, so it runs every minute. The upstream DAG A. What does it do? We have a bash operator, just print something, and then we have an external task marker, which was optional. In the upstream DAG B, we have the same behavior every minute. Later we will set it to run every 2 minutes and see what change. We also here have a bash operator, an external task marker operator, and then we have the downstream DAG that includes the external task sensors. Okay, so again, when will the downstream DAG run, or the downstream task start to run? When the execution dates of the downstreams and the upstreams are the same. Okay, let's see what happens here. So in example 2, I have to look. So this runs every minute, and the downstream runs also every minute. So normally it should, yeah, okay, so it works because every minute we have successful run of both sensor A and sensor B, which is what we expect because the execution dates are the same, right? So the upstream DAGs and downstream DAGs have all the same execution date, just every minute. Now, if I change the execution schedule to once every 2 minutes, we should see a change. Okay, in the meantime, because now we have to wait for 2 minutes, I will already go to the third example. Here in the third example, it's also sensors. And here I want to show the behavior of the time delta. I have, again, 2 upstream DAGs and 1 downstream DAG. The upstream DAGs are, again, very simple. The bash operator, the print something, external task marker, and the downstream DAG, bash operator, and then 2 sensors to sense the upstream DAGs. What is the run time? So it runs so the first upstream runs every 3 minutes, starting at 0. The second one, so the second upstream runs every 3 minutes, starting at 1. And then the downstream runs every 3 minutes, starting at 2 minutes. So in principle, when you just implement it like this, the downstream will never, so the sensor will never run in the downstream, because the execution time will never be the same as they are shifted with 1 minute. How can you solve it? You can solve it by including an execution delta. So with the first upstream DAG, we need to shift it by 2 minutes. And with the second one, we need to shift it by 1 minute. And then it works normally. I will show this example. So if we go to the downstream DAG, so this was just at the start, or not yet completed, but then all the others worked normally because we shifted in time. If you would not do the time shift, then the sensors would fail. We can have a look back to our downstream DAG. So, okay, it's still sensing. So now sensor B is still sensing for the upstream B. So this is, again, example 2, where we changed the schedule for every 2 minutes. So this is now running or waiting for 2 minutes to run. And normally now, yeah, you see it fails because there wasn't a run every minute. So this sensor, this DAG, the downstream runs every minute. Upstream A runs also every minute. Upstream B runs every 2 minutes. So now you start seeing there will be a red one, green one, red one, green one. Okay, then we can go to the dataset example. In the dataset example, it's also very easy to understand because we just define the datasets. Then we have an upstream, we have a downstream, and then we have, we have 2 upstreams that have outlet parameters. So the operator here in the upstream has an outlet parameter which tells Airflow when this task runs, we virtually modify dataset number 1. In the second upstream DAG, we say we will modify dataset 2 when this task runs. And then in the downstream DAG, we say, okay, this DAG should run when both of these datasets are updated at least once, and then the downstream runs. So this is the sensor. And then, oh, I put them. Now we go to the dataset 2. I will go to the downstream. So you see everything runs here, and it runs with, if you look to the amount of runs, so it's half the amount of runs, but because I will go back to the code. Now we can also see it here. Here, the schedule of this upstream, it's every minute, but this one is every 2 minutes. So which means the downstream one will only run when at least both of them are updated once. So it will take the same frequency as the upstream there. And that's what you see here. Then some other features of these cross-DAG dependencies. We can have a look to for the datasets or first DAG dependencies here. Here you can see an overview of all the DAGs that are interacting with each other. So for the trigger method, so we have 1 upstream trigger, and then we have 2 downstream DAGs that depend on this upstream DAG. And you can clearly see this is with a trigger. Then here you have 2 for the sensor. We have 1 downstream sensor that waits or always checks for the upstream ones. For the dataset, yeah, we have the same, and then it's the dataset that it's the coupling. Okay, so this is to visualize all the dependencies between the different DAGs. Then we can also have a more detailed view for datasets. So they made a new datasets view, and here you can see all the cross-DAG dependencies that are based on dataset with some more details. So we have upstream A, which depends on this dataset. You can click on it. And then you can also see when was the last update. And you can go to the DAGs. And then something else that I wanted to show you is the upstream marker. So I told you it was optional. The advantage here is if you go to an upstream marker, so now I'm in a sensor, an upstream sensor DAG. If you go to the marker task, you have a link directly to the downstream DAG that is linked to. And it's optional, but it's always nice to have these links. And also if you navigate in the code, you see clear dependency. So this was the second example where we modified the scheduling period of our upstream B. And there you see, if it's not every minute, there will be an error. Okay, so this was the demo that I wanted to show.
Cool, thanks. In the meantime, our video has failed, so you won't see our faces anymore, but I guess you remember what we look like, right? So thanks, Felix, for this very useful walkthrough on slides, but also on demo. I think the demo always shows, like on slides, it's nice to see the theory, but in demo, it's nice to see it in action. So thanks for that. Yeah, so for people following, we'll share the code somewhere in the links or in the description or whatever. Send an email so you can play with the code yourself. Are there any questions from the audience? Was everything clear? Do we want to dive into a particular topic? I'll wait a bit until, because there's always some delay between the stream and us live. So if there are some more questions, we're happy to answer them. If not, I think we're happy to have said what we wanted to say today. So there's nothing coming in. I'll wait for a bit more. So maybe while we wait, Felix, if you use Airflow in practice, and now you delved into all the options, but are there any of the techniques that you have a preference for yourself?
Yes.
Do you like which one?
So my preference is the dataset method because it takes away all the time management that we normally have to put in our DAGs. So if we have cross-DAG dependencies, previously it was with sensors, and you need to always take care of the timing with this execution. So the time shift you need to take into account. When you have several dependencies between DAGs, this can become complicated.
Yeah, for sure.
That's the nice thing about datasets, that we don't have to worry anymore about these timing things.
But that is true with all VA set as well. If you have a DAG that depends on, let's say, 6 different data sets because you want to do a big integration job or whatever, and there's just one of them is not there, it might be good enough from a business point of view. So you know what, we're just going to take the one from yesterday or whatever. We're not going to wait for the update. It needs to run at 6 a.m. anyway, right? So, and then today like the data set based triggers, you have to have all the data sets need to be updated or else, right?
Mm-hmm. Yeah, so if there is really a time issue over there, it's really a time that needs to be fixed, then sensors can also be used. Yeah. So for example, with the marketing automation deck that I showed in the beginning of the slides, there you often have the case you want to send a mail in the evening, for example. So it has to be at 6 a.m. and not when a data set is updated. So in these scenarios, you want to work with sensors where you have control over time.
Exactly. Yeah. All right, cool. Thanks a lot for the detailed walkthrough. So for the people in the stream, thanks for joining. We'll be there next time, maybe with a video, who knows. Thanks all for joining, and see you next time. Bye, everybody.
Bye.